Everyone, welcome to Manmaker. I am Ranjan Kumar, and today we are going to continue our classes. And today class we are going to cover communication system. As you know, and like this class is for belongs to electronics branch and electrical branch because communication system syllabus is there in both the branches. Okay, so as I have already discussed previous year question and all, so there also I gave subject wise weightage, so there you can check also, like from communication system in electronics engineer almost 18 to 20 question they have asked in previous year. Okay, so weightage will be like this only. This time also you are going to get around 20 question like that you will get from communication system. Then for electrical engineer, the weightage of this subject is around, you will get around 10 to 12 to 15 question you are going to get from communication system. Around you can expect around 12 to 15 question from communication system. And for electronics this is a very important chapter, so today we are try to cover all this thing. As you know, communication system have two parts: analog communication and digital communication. So we will cover these two thing in two classes. Today we are going to discuss analog communication, full analog communication, whatever there in analog communication in today class we are going to cover. Okay, for pdf and more updates you can join our telegram channel, and whatsapp group is there, you can join both of these. Here I am sharing class update, study material, notes, and job update. Everything you will get here only. And now you can access your study material from the app, the Mann Maker, in the Google Play Store. Just go and download. There you can access your exam study material. Okay, and I hope you are preparing well with this app material. Everything is there for probationary engineer, so you can take and start your preparation. All right. Okay, so we'll start. First we are going to see our syllabus. So here first we are going to cover introduction of communication system. After that we'll see what are the elements are there for a communication system, then type of communication, then we will jump to our type. Like we have two type, analog and digital. So in analog we are going to see modulation and modulation technique. After that we'll see about continuous wave modulations and their techniques. Then we'll discuss about noise and SNR. Then we'll complete digital electronics. In that we are going to cover sampling theorem, pulse modulation, digital modulation, and digital modulation schemes. Okay, after that we will see information coding, information theory and codings, then multiplexing and modems theory. Okay, so this all we are going to cover for a communication system. All right, so we'll start from the starting, like communication system. Generally, when we will talk about communication system, communication means what? It is the way of interchanging or exchanging our information. By the definition, if you see, communication is the process of transmitting information from one point, that is your sender, to another point, that is your receiver, using a medium or a channel. Okay, it is the way to exchange our information. So for that we required some elements or component for communication. That will be your source, that is your sender. Okay, sender part. There one transmitter is there, and after that you will find one medium or channel that will transfer your information till receiver, and after that it will go to destination, that is your receiver. Okay, and in channel also you will get some kind of noise, so we'll discuss for that also. So this is the block diagram for a communication system, which will like basically it is a communication system block diagram. Okay, now if we see like whatever component we have used here for a communication, first if we talk about our transmitter, see transmitter. So what is the function of a transmitter? Is used to convert the message signal into a suitable signal for a transmission. Okay, transmitter will, whatever information is there, whatever signal or whatever you are transferring, the function of a transmitter is to convert that message signal into a suitable signal for a transmission. Okay. Then channel and medium. This channel and medium, the function of a channel is to carries the signal from a transmitter to receiver. Okay. It will only carry that information from transmitter to receiver. All right. And receiver, what we do receiver same thing as a transmitter only. So a receiver side, receiver will convert the received signal back to our message signal what we send from the transmitter. Okay. And noise is what? Noise is generally unwanted signal which will affect the signal, or it will destroy the signal information that we send from the transmitter. Okay. So this is the basic definition of our communication system. Okay. Now, based on this, like as I told, it is the way of exchange of our information. So like that we can categorize this type of communication based on a signal type, based on our direction type, and based on medium type. So in three way we can categorize communication system. Okay. Based of signal type, if we see, we have analog communication and digital communication. Analog communication, in that we will see about continuous time signal, how communication happening with a continuous time signal, that we are going to see in a analog communication. And like if you see example, radio and television, that are the example of analog communication. Now, digital communication mainly here, in a digital communication, it will deal with discrete time signals, okay, like our internet and mobile communication. So this is the example of digital communication. Now, based on direction, we have three ways. Either we can transfer our information in a one-way communication. One-way communication means only we can transmit that signal or we can receive that signal. We can't reply. Means one way only we can do. Means like if you talk about television broadcasting, like we have television, there we are watching newses and live match telecast and all this thing watching. So we can't reply to them. We get information from there. Like suppose I am watching new channel right now. So I am getting information from there. They are transmitting the information, but I can't reply to them. Okay. So this is what one-way communication. You will only transmit the signal. Okay. So this is what this is called simplex. Now we have half duplex. Half duplex means what? Two-way communication, but one direction at a time. That means what? Two-way communication means what? We can like we can transmit also and we can receive also, but at a time. Like at a time only we can transmit. Like we have walkie-talkie. Okay. I will tell something from walkie-talkie from here to that receiver will receive the message. After that he will press one button, and after that he can reply. He can again transmit from their side their message. Okay. So at a one time we can send our information, then we can receive our information. So this is what two-way communication, but one direction only. Now if we talk about full duplex means what? Two-way communication at a time only. In same time, simultaneously, we can transmit and we can receive our signal. That is your like telephone or mobile communication. What we are doing, that is your two-way communication. Like here, like you are taking now classes. So this is a simplex. Okay, simplex communication. I am only giving, I am teaching you right now. Whatever, suppose I will tell something mistake, I will tell some mistake thing now. You can't reply to me. Okay. But like we will do live classes, that is you can say full duplex communication. There you can give at a time, you can also whatever I will ask, you can give the answer for that. Means at a time we can do transmit and receive the signal. So these are the based on direction. Now based on medium or channel, we have two type of communication, that is your wired communication and wireless communication. Wired communication via cables, like we have coaxial cable, ethernet cable, and optical fiber is there. So that is your wired communication. And for wireless communication, that is through a ear using a EM wave, like our Wi-Fi or satellite communication. So these are the way of communication, how we are exchanging the information. So we can classify like that the communication. All right. Now the first as there are two type of communication that we have discussed this thing based on signal. So based on signal only we are going to discuss in a communication system. Okay, so first we are going to cover analog communication. So analog communication system, if we talk about analog communication system, so analog communication system is what? In that, it is the process to transmit analog information like our sound, voice, audio, anything like in analog form using a continuous waveform over a communication channel. Okay, using a continuous waveform. This analog means what? Continuous waveform. Medium will be your continuous waveform. Like that, we will send our information like analog sounds and video, how we are transmitting that. Like for example, if we see our human voice, like our voice over a telephone, that is what analog communication. FM radio broadcasting, that is also your analog communication. Now public address system, it is also a communication, analog communication system. Basically, like if we suppose take our voice, okay, our voice, so it will be what? Generally we have analog voice. Our voice will be go like this. Okay, this we call message signal. Okay, this we call message signal. Okay, you can say M of T. Okay, this is your what? Message signal. Message signal will go like this, and after that, to transferring, like my voice is there, to transfer my voice we need one medium or carrier. So that we call carrier signal. Okay, we will pass this signal, this message signal, with a carrier signal. All right, this is amplitude, this we call CT, this carrier signal. And after that we will do superimposing of this both, and then after superimposing, one term will come, that is your, we call this thing modulation. Okay, this is what? Modulation. This is what? Modulation. So via modulation, like right now I am talking with you, I am only speaking, then how it is going to, how you are going to listen my voice and all. Anyhow, right now this is a part of whatever we are doing right now, like video transmitting. So this is via digital communication. But suppose like a short distance, like a telephone using landline, my voice is there, they will transfer this information. How? They will first take one carrier signal, in that you will they will put your message signal whatever I am speaking, and after that they will do superimposing, that is your modulation, and after that your voice will be transferred to the receiver. All right, so basically if we talk about modulation, so modulation is what? Modulation is the process in which characteristic of a carrier signal is varying according to the message signal. Okay, or you can say modulation is the process of superimposing a low frequency message signal into onto a high frequency wave for a efficient transmission over a long distance. Like our voice is there, that is what, that we have our voice is what? Low frequency. Okay, our voice is what? Our voice is low frequency voice signal. If we talk about our voice signal, so that is what, generally, our wave signal is 300 Hz to 3 kilohertz. This is what our voice signal. So this is a low frequency, and we need to transfer this low frequency in a far away. So for that we need a high frequency carrier. In that we can superimpose our message signal, and it will transfer to transfer for a long communication. So for that some criteria is there, why this modulation is required, why it is needed. We have more points like why need of modulation, but we have mainly some points are there for that modulation required. Like if we talk about the first, that is your transmit signal over a long distance. Okay, for like for a low frequency like our voice signal. So for transferring this our voice signal to a long distance, we need a carrier signal. Okay. Suppose FM. FM is what? This is your message frequency. Okay. Message signal frequency. So it should be greater than, much greater than with a, sorry, FC. This carrier frequency is there. That is your high frequency. That should be much greater than with a message signal. Then modulation will be go perfect. So for by doing this only we can transmit our signal in a long way. Okay, long distance. So this is the first thing, like for a long distance, over a long distance we need to transfer our information. So for that modulation required. Now if we want to send our message signal in a long distance, so for that we required antenna also. And suppose if we not do modulation, then the antenna size will be big, and if we do modulation, then it will reduce the size of antenna. So that is the main part of our modulation. So it will reduce the what? Reduce the size of antenna. Suppose like if we talk about a voice signal, as I told, our voice signal will be how much? 300 hertz to 3 kilohertz. This will be what? Our voice signal. Now first thing, this part I am just talking about this part. To transmit a signal over a long distance, as we have voice signal 300 hertz to 3 kilohertz. Now if we talk about our FM radio, the range of FM radio is what? FM range. Okay. FM range is how much? It will be your 88 megahertz to 10 hertz megahertz. Okay. I think you are listening radio and all. So in that radio you will find this range 88 to 108. Only our radio station are there. In this range only our radio station are working. So we are transferring our voice using this frequency. Only that we can listen that radio anchor or RJ sound and all these things. All right. So now suppose how it will reduce the length of antenna. So for length of antenna, we have a formula, that is your L equal to lambda by 4. Okay. And lambda is what? We can write this is C by 4f. Like that also we can write. C is what? C is your velocity of light. That is your 3 into 10 to the power 8 meter per second. Okay. And 4 into, suppose f. Now as if we not put a high carrier frequency, like without carrier frequency, without high frequency, we are transferring the our low, our voice, like our voice, the range of our voice is what? 300 hertz to 3 kilohertz. This will be our range. Okay. Suppose I will take low frequency. So in between, suppose we will take 1 kilohertz. Okay. Our voice, if we take 1 kilohertz, I want to transfer my message that is of 1 kilohertz frequency, message signal frequency that we want to transfer. So our message signal is how much? 1 kilohertz. 1 kilohertz means what? 1 into 10 to the power 3 hertz. This is only. So now if you calculate this thing, so it will come around, this will 3 into 10 to the power 5 and 4. Okay, you will get like this. So after calculation on that, you will get 75000 meter. So 75,000 meter antenna required if you transfer to if you transfer 1 kilohertz message signal. If you calculate this thing in a what kilometer, so 7500 divided by 1000, that is your 75 kilometer. So 75 kilometer long antenna required to transfer 1 kilohertz message signal. Okay. And suppose if we take carrier signal, now if we do modulation and all, and will take a high frequency. High frequency means, like suppose in this range 88 megahertz to 108 megahertz, Suppose I am taking now frequency will be our 100 megahertz. Okay, in the range of FM signal I am taking. Okay, FM radio signal. So this will be same. It will come 3 into 10 to the power 8 meter per second and divided by 4 into 1. Sorry, one. How much it is? 100 megahertz. So 100 megahertz it will be. So we can write this one 100 into 10 to the power 6. Okay, 100 into 10 to the power 6. So here it will come how much? 3 by 4. So if you calculate this thing, you will get in a point, some point you will get, that will be in meter. So 0 point something meter you are going to get the antenna size. Okay, so how it will reducing the size of antenna, that you come to know, I think. Okay. So now the next is why it is required to enable a multiplexing. Okay, so over a modulation, if we do modulation, then same means it can share the same channel with a different frequency. Like suppose the radio signal, if we talk about FM radio, that is your 88 megahertz to 10108 megahertz. So in this range of frequency only, in this range of frequency, we can use a different type of channel. Like you are listening around like 104 is there for Radio Mirchi, and 99.1 megahertz is there for other radio channel. So like that, we have in India, I think three or four or five channel is there. 103 is a Bibit Bharti. So like that, in the same range of frequency channel, we will use a different channel using a multiplexing. Okay, and the main point is to improve the signal quality and the noise immunity. Okay, so after modulation, it will reduce the noise also, and it will improve the signal quality also. That's why we are using this modulation technique. So basically, these are the four important point is there why modulation required. Just keep in your mind. Okay. Now, if we talk about our type of modulation, now we have different type of modulation. By them, we are transmitting our information from one palace to another palace. All right. So like we have two type of modulation is there. First one is your continuous wave modulation. Okay, continuous wave modulation, or we can say analog modulation. Okay, and we have pulse modulation or digital pulse modulation, you can say. No, it is a pulse modulation. Okay, now in a continuous wave modulation, we have two type of modulation that we called analog modulation, sorry, amplitude modulation and angle modulation. Okay, this continuous wave modulation is also called analog. Okay, analog modulation. So there are two type of analog modulation or continuous wave modulation, that is your amplitude modulation and angle modulation. All right, further angle modulation is divided into two part, that is your frequency modulation FM and phase modulation, that is your PM. Okay, these are the type of analog modulation or continuous wave modulation. Now, if we talk about our pulse modulation, so pulse modulation is also a two type. First one is your digital pulse modulation and another one is your analog pulse modulation. In digital pulse modulation, there are three type of digital pulse modulation. First one is your PCM, that is your pulse code modulation. Then another one is your DPCM, differential pulse code modulation, and DM, that is your delta modulation. So we are going to see everything. Now if we talk about analog pulse modulation, in analog pulse modulation also we have three types, that is first one is PAM, that is pulse amplitude modulation. Then we have PWM, that is your pulse width modulation, and another one is your PPM, that is your pulse position modulation. So we are going to cover all the types in a details. Okay, so we'll start first, that is our continuous wave modulation. Okay, first we are going to see about continuous wave modulation. Now, if we talk about continuous wave modulation is what? Analog modulation only. So in analog modulation, we have two type. That is, first one is your amplitude modulation and another one is your angle modulation. Okay, so amplitude modulation is what in which the carrier characteristic of a carrier is varied according to the master signal. Characteristic of the amplitude. Okay, amplitude of the carrier wave is modified according to the master signal, while in this frequency and phase are remains constant. This is the definition of amplitude modulation. Amplitude modulation is what? It is the modulation technique in which the amplitude of the carrier wave is modified according to the master signal while the frequency and phase remains constant. Okay, so in this also we have one master signal and we have one, like our master signal is there. This is our master signal. So in this master signal we are superimposing our carrier signal with a like high frequency. We have this is a uh, low frequency and this will have a high frequency. So after superimposing it will produce a modulation. So this is what, this is the modulation. After modulation our waveform will be like this. Okay, this is what, this is modulation. All right, so like we have, this is master signal, this is what, m of t. Okay, this is master signal and this is c of t is your carrier signal and this is your s of t is what, modulation signal. So if we talk about our master signal, that is your m of t. Okay, here I am writing. Okay, here only. So m of t is what? M of t is your am cos 2 pi fm t. This is what? This is master signal. Now we have c of t, that is your carrier signal. So carrier signal is what? AC cos 2 pi fc t. This is carrier signal. Now we have st, that we call modulation or okay. So this is what, this is your AC plus m of t cos 2 pi fc t, or you can say AC, you can take common, is 1 plus mu cos 2 pi m of t and cos 2 pi fc t. This is the general equation for amplitude modulation. Okay, this is the general equation. Okay, amplitude modulation, general, or you can say standard. General equation. General equation of amplitude modulation is what? AC 1 plus mu cos 2 pi fmt and cos 2 pi fct. Okay. In this, you can see this is a what? Mu. Here mu is there. So mu is what? Mu is what? Here in this equation, just a second. In this equation, mu is what? Mu we called modulation index. Okay, mu we called modulation index. All right, so modulation index is what? Mu. Modulation index is am by AC. Okay, am by AC, modulated amplitude and carrier amplitude, the ratio of modulated amplitude and the carrier message amplitude or carrier amplitude. So the condition is there when this mu is, we will get less than 1. Okay, suppose this, the value of this mu is less than 1, then we call this is what? Under modulation. The modulation is called under modulation and this mu is equal to 1. In that case it is called perfect. Okay, perfect modulation, and this mu is greater than 1, then it will call over modulation. Over modulation. Okay, this is important. So in a objective type like MCQ type question, they will ask this thing. So just remember this is the condition of modulation index. Okay, this you need to remember. Now if you see the frequency spectrum of amplitude modulation. Okay, frequency spectrum of amplitude modulation, that is here it will be somehow like this. Your spectrum will come. It have a carrier signal. This is what your FC carrier signal. Here we can write FC, and we have this one is your upper sideband, and is your lower side band. Okay, here this will be your FC plus FM upper side band, and FC minus FM, that is your lower side band. Okay, and the bandwidth of AM bandwidth of AM is what? 2 FM. Okay, just remember this point. Bandwidth of AM amplitude modulation is what? Twice of frequency modulation. All right. Now, if we talk about main amplitude modulation technique, so we got how modulation is going on in amplitude modulation. Now we have some kind of techniques is there for a modulation. Sorry, amplitude modulation, by that modulation happening in a amplitude modulation. So basically we have three types, that is your DSBSC, that is your double sideband suppressed carrier technique, and SSB single sideband technique modulation technique. Then VSB vestigial sideband technique is there for a modulation in amplitude modulation. Okay, in DSBFC, as it is a suppressed carrier, so in this carrier will be suppressed. Okay, carrier will be suppressed, only sidebands are transmitted, upper sideband and lower sideband are transmitted, and the bandwidth here, bandwidth is also twice of FM, and this is power efficiency is better, is here better in the DSB-SC. Okay, if we talk about SSB, in SSB it will be only, suppose, okay, we will see frequency spectrum, then you will come to know spectrum. Okay, if we talk about frequency spectrum of this DSB-SC, so here it will be same like amplitude modulation. Here you will get spectrum will be like this. In that frequent carrier signal is suppressed. Okay, carrier signal is suppressed, and this is what upper sideband. This is your FC plus FM, and this is your FC minus FM. Okay, likewise this is your here this suppressed carrier, this is your FC, and this is your minus FC. So this will be your, this point will be your minus FC plus FM, and here minus FC and minus FM. Okay, this is the spectrum, frequency spectrum diagram of a DSB-SC. Now SSB is what? Single sideband. In that single sideband is what? Here only one sideband is will transmit either low LSB, that is low sideband, or upper sideband, lower sideband or upper sideband. Only one sideband will be transmitted, and here the bandwidth will be your FM, and here also carrier will be suppressed, and power efficiency is high here. Okay, power efficiency is high here. So if you see the diagram, either it will transmit one on, okay, either low side upper sideband or lower sideband. So this is your FC, that is suppressed carrier, and here it will be FC minus FM, that is your low sideband. So here also low sideband is your minus FC plus FM. So this is also LSB, and this is also LSB. So it can transfer only one sideband. All right. Now if we talk about VSB, vestigial sideband, so in that one sideband, they will transmit one sideband and a part of vestigial. Okay, like, and here carrier signal will be present partially. Like if you see the diagram, it will come somehow like this. Suppose one side bend, it will go this part, okay, and some part of visitizer, okay, like that. Here you can say this is the low side band and some part of visitizer. So this will be what? This is your FC. This will minus FC. Okay. This is your information. A means FM, and this is also your information, message signal, message frequency, so FM. This is the diagram of VSB, okay, which it is a side band. All right. Now if we see modulator and demodulator, in amplitude modulation or any kind of modulation is there, in that two things are there, modulator and demodulator. Modulator means what? Modulator, generally we are using transmitter side to modulate our signal, okay, and demodulator we are using receiver side. All right. So modulator is what? Modulator, generally it will combine the carrier signal and message signal to produce the amplitude modulated signal. Same demodulator is what? Demodulator, what it will be do? It will be used in a receiver side, and it will extract the original message signal. In the receiver side, demodulator, it will extract the original signal. This is the function of demodulator. All right. So if we talk about type of modulator, in that modulator of AM, like amplitude modulation, we have square lobe modulator, we have switching modulator, then balanced modulator and ring modulator. These are the type of modulator in the AM. Okay. And if we talk about demodulator, so in the demodulator we have envelope detector, a square law detector and synchronous detector, that is also called coherent detector. These are the type of modulator and demodulator in the AM, that is your amplitude modulation. Okay. Now if you now we are going to talk about power calculation in AM, that is your amplitude modulation. So generally we will calculate power in term of uh, carrier power, sideband power and total power. So first if we talk about carrier power, that is your PC. Carrier power means what? PC. That is your, just a second, that is your VC square divided by 2R. Okay. Carrier power is what? P is power, carrier power is equal to V square, VC square divided by 2R. VC is what? VC is your peak carrier voltage. Okay. VC is your peak carrier voltage. Okay. Peak carrier voltage. And R is what? R is your load resistance. All right. Load resistance. Now, if we talk about total power, how we are calculating total power in AM? So that is your PT, and PT equal to PC 1 plus mu square by 2. Okay. PC is what? PC is a carrier power. So this is the formula to calculate total power. And here mu is what? Modulation index that we discussed before. Modulation index. All right. Now we have sideband power. We have sideband power, that is your PSB. PSB, P upper sideband equal to P lower sideband. Okay. For both upper sideband and lower sideband, same formula is there. That is your PC mu square by 4. Same formula is there for upper sideband and lower sideband. Now in that, before, while we are doing we are seeing our different type of modulation, in that we have seen modulation technique, we have talked about power efficiency. So how we will calculate power efficiency? Okay, power efficiency. So power efficiency generally we will denote with eta, and that is equal to power sideband divided by power total and into 100. That will you will get in a percent. So it will be eta equal to mu square divided by 2 plus mu square into 100. So this is the calculation of power efficiency in AM. Okay, like this we are calculating the power efficiency in amplitude modulation. Okay, now here we have discussed one type, that is our amplitude modulation. Now we are going to discuss another continuous wave modulation, that is your angle modulation. So angle modulation is what? Angle modulation. Angle modulation is the process. Angle modulation is the process in which the frequency or phase of a carrier signal varies according to the message signal. In amplitude modulation, amplitude of the carrier signal was varying according to the message signal. Now in angle modulation, either frequency or phase will vary according to the message signal. Okay, when frequency will vary, when frequency of the carrier signal is vary according to the message signal, then it will called frequency modulation. And when phase of the carrier signal varies according to the message signal, that time it will called phase modulation. Okay, so this is the basic definition of your what frequency modulation and phase modulation. Now if you see standard equation for angle modulation. Okay, for angle modulation, so it will be your st. We have one message signal and carrier signal, and we have st, that is your standard equation for amplitude modulation or angle modulation, whatever. So this is for angle modulation. It will be your AC cos theta I and T. Okay, this is the standard equation for angle modulation. Standard equation of amplitude modulation we have also discussed. So this is standard equation for angle modulation. Now we'll talk about frequency modulation. So frequency modulation, I told in that frequency of the carrier signal varies according to the message signal. So same here also we have one message signal, and in that we have one carrier signal. Okay, this is what message signal and this is what carrier signal. So after superimposing, we will get our modulation, FM modulation, like this. Okay, this is what FM modulation diagram. Like this will be your amplitude, sorry, frequency modulation will go. All right. So this is what frequency modulation is happening. So here also we have this message signal and carrier signal, and here also we will get standard equation of FM. So if we talk about standard equation of FM, that is your S of T is equal to AC cos 2 pi FCT plus 2 pi KF, okay, 2 pi KF, and integration of M of T dt. Okay, this is the this is the standard equation. This is the standard equation for frequency modulation or FM, you can say. Okay, here this KF is what? This KF is called frequency sensitivity sensitivity. This is called frequency sensitivity KF. Okay, now here also we are in frequency modulation, we have modulation index, modulation index. As in amplitude modulation, we have calculate our modulation index, that is mu. Here we are denoted by a beta, that is B, and beta is equal to what? Del F divided by FM. Okay, del f, that is frequency, deviation, that is your kf and am. Frequency sensitivity and mass amplitude massive signal. Then this is divided with fm. So this is what beta. All right. And when this beta, here also condition is there, two condition is there, when this beta is less than 1. Okay, when this beta means modulation index is less than 1, less than 1, then it is called NBFM, that is your narrow band FM. Okay, and when beta is greater than 1, okay, when beta is greater than 1, then it is called wide band FM, WBFM, wide band FM. So two condition is there for modulation index. When beta is less than 1, then it is called narrow band FM, and when beta will go greater than 1 or higher than 1, then it is called wide band FM. Okay, so just remember these 2 points. Now, another modulation is what? Of angle modulation, it is your phase modulation. So, when the characteristic carrier of a phase will change according to the master signal, then it is called phase modulation. Okay. In phase modulation also we have master signal and carrier signal. Okay. This is M of t and this is C of t. All right. And after superimposing, we will get like this our phase modulation. We are going to get like this. All right. This is amplitude, and we are going to calculate our S of t. S of t is what? Standard equation of PM, phase modulation. That will be your ST is equal to AC cos 2 pi FCT and plus Kp m of t. All right. This is the standard equation for phase modulation, where this Kp is called phase sensitivity. Phase sensitivity. Okay. So this is the standard equation for phase modulation. Now you need to remember some point. Kindly note it down. Some points are there like PM. Our phase modulation is used in mobile communication. Phase modulation we are using generally for a mobile communication, and frequency modulation, that is our FM. Generally we will used in a FM broadcasting. Okay, frequency modulation we are using there. Now bandwidth, if we see the bandwidth of a angle modulation, so it will be bandwidth is equal to twice of del f plus fm. This is the bandwidth calculation for a angle modulation. This is same for both phase modulation and frequency modulation. All right. So this is the bandwidth of a phase modulation. Now, as we have modulator and demodulator in amplitude modulation, same we have modulator and demodulator in angle modulation also. So modulation is what? A modulator is what? Here the modulator will be, it will combine the same carrier signal and the message signal and produce the angle modulated signal. Same for a demodulator also, it will extract the original message signal from the received waveform. All right, same definition is there for modulator and demodulator. So in an angle modulator, we have uh, direct method for modulation, and indirect method is there. In indirect method, we have Armstrong method and using differentiator method. So Armstrong method is generally used for FM, and differentiator method is generally used for phase modulation. All right. Now, if we talk about our demodulator, so in demodulator we have frequency discrimination method for FM, Generally, to demodulate frequency modulation, we used frequency discrimination method, and we have phase description method for PM, phase modulation, and another one is phase locked loop, that is your PLL demodulator. All right, this is the modulator and demodulator of an angle modulation. All right, now noise is what? Now we will talk about noise. So noise is what? Noise is generally, it is the unwanted signal which will affect our original signal. Okay, noise is an unwanted signal which is interference with the original interference with the original message signal and corrupt the parameter of the message signal. Okay, the function of noise basically this is only. All right. So we have two type of noise. One is external source and through internal source. Both source we have for a noise. By that our channel, our information will affect. So, for example, in an internal source, example is there for like atmospheric noise is there externally, then solar noise, cosmic noise, and industrial noise are there. Due to that, our signal will corrupted or going to destroy. All right. And internal source, if we talk about internal source, so in that you will get thermal noise. So basically, internal source is due to components and internally components and physical things. Due to that only this noise happening, like thermal noise. Due to heat of temperature and all on the component, we will get thermal noise. Then short noise is there due to random movement of electron and holes in a components. Short noise occur. Then we have transit time noise. During the transition of a signal, this transit noise arises. Okay, so these are the two type of noise is there in a communication system externally and internally. Just remember these points. Okay, now we'll talk about SNR. SNR is what? Signal to noise ratio. Okay, SNR is what? Signal to noise ratio. So signal to noise ratio, it is the ratio of signal power to noise power. Okay, it is the ratio of signal power to noise power. The higher value of a SNR, the greater will be the quality of the received output. If the SNR value is high, as much as high means for the greater value of SNR, we will get the better quality or greater quality of in the output. Okay, so our SNR should be high as possible as. Okay. So this is the ratio of what? SNR. SNR is the ratio of signal power to noise power. All right, signal power to noise power. Like we have calculation of input SNR. Okay, input side how SNR will be. So it will be the average power of modulating signal. Modulating signal. So input side generally we will modulate our signal. So that's why average power of modulating signal to the average power of noise. Okay, at input side. Okay, so this is the input SNR formula. Now for output SNR. So for output SNR, same average power of demodulated signal. Demodulating signal, as in the output side we will demodulate the signal, so average power of a demodulating signal and divided by average power of noise at output. Okay, so this is the basic formula for SNR. Okay, in input side and output side. And now if we go the ratio of SNR output divided by SNR input. So the ratio of SNR output and SNR input is called FOM. FOM is what? Figure of merit. Figure of merit. Okay, this is called figure of merit FOM, figure of merit, the ratio of output SNR to the input SNR. Figure of merit is used, it will check the performance of a device. Okay, to check the performance of a device, we will calculate the figure of merit. All right. So this is the basic, means this all things I have covered about analog modulation or analog communication. Okay, analog communication I have covered. Communication. In the next class, I am going to cover digital communication. Then in the further class, we will discuss some questions which came in previous year also, and they can may like you can may expect some question like that question we are going to discuss. So these all the things already I have covered in ebook, okay, which is available in this app, the Mann Maker, which is in you can download from Google playlist. So here in this, what you will get in study material, you will get one ebook. So here you will get subject wise notes and subject wise MCQ is there that you need to cover. Okay, then 500 important question you will get with explanation of answer, and mock test is there technical. 150 general aptitude question is there and mock test is there. Full mock test is there that you need to perform test series. Okay, then previous year question you will get there only, and interview question and answer is there, and classes is going on YouTube. So this thing you need to get from the app. Okay, just go or to Play Store, there you can download, or go to below description box, you will get link. Just take this one and complete your preparation. Okay, so we'll meet in a next class with digital electronics, sorry, digital communication. Okay, so I hope you enjoyed this class. If you like this class, just hit like on a button, kindly share with your friends, and if you not subscribed my channel till now, just subscribe the channel and comment below also how you like this class. Okay, okay then, thank you.